Clits out, we're going to go to 49 real quick. Okay, so you have an example. Put our devices away, right? You have this gigantic handout. That's a picture. This is actually, I don't know how old this is, but I remember putting it on the board for students to review. And so I will talk a little bit more about this tomorrow. And notice what I did is if you fold it in half, right? You've got its hole punched on either end, then it just fits in your binder nicely. Just fold it. I hope this helps. It's kind of nice to have an overview of all the functions as we cover them. Okay, so let's go to page 49. I just need to give you one example, and then you should be able to work this out, because it's really just one step back from word problems, right, where you get the equation. And so in this case, I just need you to remember that the calculator can only perform natural logs regressions. So you gotta, don't mix up lin reg with natural log reg. Okay, they're right. I feel like it's a terrible way to arrange them because they're right next to each other on your calculator. So you have to make sure you mix that up. Okay, you gotta, don't pick 8. You pick linear, natural log. Sorry, regression. Yeah, go ahead. Okay, so let's go ahead and do that. The flash for most digital cameras requires a charge capacitor to operate. The percentage charge Q remaining in the capacitor was recorded at different times t after the flash had gone off. Page 49. T5 flash duration represents a time until the capacitor only has 50% of its initial charge. That would be half-life, right? T5 flash duration also represents the length of time that a flash is effective. That's very important, guys. T5 also represents the length of time for the flash to be effective. That is probably going to be a little, that's going to come back when we come up with a domain and range. It's only effective after that. The flash, if it's lower than that, you're not going to get a good picture. Okay, to ensure the object is being affects domain and range, right? Most likely. Okay, there's some kind of limitation put on there. And so let's go ahead and calculate that. We're going to make this L1, this L2, and this is X and Y. So go through the motions. It shouldn't take us that long. We'll just enter this into our calculator so you know how to work it. So there are no hiccups when you, tomorrow I'll do a quick AC on. And before you continue, guys, just take a quick moment to double check. Just do that, please, because even if you're off by a little bit, everything is off. And now I'm going to go over to the next 0, 0.01, 0.03, 0.05, 0.07. Make sure you don't think there's a pattern. There may or may not be a pattern. 13579. 13579. So I checked. This is my initial okay. So we can do a scatter plot, right? If you want a scatter plot, just make sure plot 1 is turned on, and then we go zoom 9, right? And then there you have your scatter plot. It looks logarithmic. It's going to cross the x-axis. So let's go ahead and perform the regression, right? We can do this, right? There's our scatter plot. Plot 1 has to be on. Okay, then zoom 9. Trust me, after we do finance, we'll take a pause from this, and then you're going to want to remember these things, right? So we go stat, calc, ln reg, and there we go. Stat, calc, linear regression, not linear regression, natural log regression, and the same thing as before. And there it is, 0.4 6, right? Sorry, I'm mixing it all up here. Minus 0.0998. I'm going to go 0.0998 so I don't have to round it to a 1. And then it's ln x like that. And I will note that this is charge is my x and time is my y, right? Remember that? And we won't trick you when you're given a table. The first variable is always x. Use the logarithmic function to determine, right? To determine T5 flash duration. And what is T5? It's when you only have 50% remaining, right? So 50% charge. That means that charge remaining. That's what that means, right? So we know that the charge represents our x variable. So we're going to go second, trace 1, x is equal to, should I go 0.5 or 50? That's the big question here. Because you're told when it's percent, turn it into a decimal, right? How did you enter it? You entered it as a percent. You did not turn these into decimals, right? So you need to enter it exactly the way you've entered it before, so be consistent. So 50%, and it's, y is equal to, we're going to figure that out, right? How long that would take. So we go I'm graphing it first of all. Then I'm going to go and adjust my window just a little bit. Y min should be -5. X max, that's pretty good. Y min is good. Y max, I should probably go a little higher. Let's say 1. There you go. That's good. So second trace 1, x is equal to 50, and there it is, 0.069. 0.069 seconds. And you might think, well, isn't it 2 decimals? Yes, it's 2 decimals minimum. If you do more, it's also okay, right? So to the nearest hundredth of a second, so that would be 2 decimals, right? So it would be 0.07 in that case, or 0.07 seconds, right? It doesn't ask for the domain and range, but what would be your domain and range in this situation? When it comes to domain, right, we're put a restriction on there because my domain, we're talking about percentage remaining, right? And so the lowest we can get for percentage remaining is 50. Okay. So we're going to go 50 all the way to 100. Right, 100% would be ideal, fully charged, right? Most of the flash. 50 is, it comes all the way from up there, right? All the way from up there. And then, so for range, we're talking time, right? So time would be as low as 0. Does that make sense, right? Because we're touching the x-axis, and in this case, time is here, right? So the lowest time is 0, right? It's a little backwards, like, logarithmic, right? Why can't you just stick with exponential, right? But so the highest time would be restricted by this, right? Knowing that the flash has to be 50% or more. So 0.07 or 0.069, whichever you prefer. Just make sure lowest first, largest second, right? And then you got that part down. And there's something I wasn't going to talk about, but I think a lot of teachers do it, and it's something that is actually quite popular. Before we go, you just need to remember the word asymptote. Asymptote. So come with me, join me for the ride. I'm going to take you back in time. Where's logs, 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 logs? Here it is. Go to page 33. And I always think of Lord of the Rings. You shall not pass when I think of asymptotes. Okay? So for logs, logarithmic, it never touches the y-axis, correct? So I'm gonna pick a highlighter and just a dashed line like this. And this is called an asymptote. What? Asymptomatic carrier? What? Asymptote. And the asymptote is the line x is equal to 0. Let's do that one more time. You can also use it in sentences such as, you're such a pain in the asymptote. You know, you get creative and you'll remember it, right? All right, and then next, there's one more. Where is the asymptote going to be for exponentials? Y is equal to 0, because remember, we do this. It never touches the x-axis, remember? So let's go even further back in time, going back to the 80s or further. Could it be on a multiple choice or something short answer? Maybe. So it never touches the x-axis, so we're going to do that here. Asymptote. And that's the line y equals 0. Y equals 0. That's on page 3, guys. If you're wondering, where am I? Page 3, way at the beginning. Okay, so I wanted to talk about that. If you take that gigantic handout, I don't know if you want to use the same highlighter. It's actually, if you look carefully, it does say it there. Like, look at this. Can you make out what that says right there? Asymptote, asymptote. So okay. And for us, those are the only two asymptotes we're going to talk about, but it's there, okay? I gave you a handout, so if you wanna have more, that was going to be my test review handout, but we're not done yet. He's never done. I know there's so much. We're on page 49, right, doing that regression. So there are more questions following that. I have the key to that. So when you get to 49, I will just say homework, whatever follows that, make it right till the end. So that would be page, let me just check real quick. 50 to 54. Page 50 to 54. I think I mix up logarithmic and exponential. I would have to check that. I'll freeze that right there. Logarithmic, logarithmic. It's all logarithmic. So if you want to mix up, if you want it mixed up, you've got to use that handout that I gave you. Okay. So thank you guys.